Good day, sir. I'm Nessa C. Cardanio, taking up Bachelor of Elementary Education, 3rd year, Class 1. The two topics that I will discuss today is all about, first, triangles, second, quadrilateral. The first topic that I will discuss today is all about triangle. My learning objectives is at the end of the triangles lesson, students will be able to tell what an isosceles, salen, and equilateral triangle looks like. Second, students will be able to measure the sides of a triangle. Last, students will be able to measure the triangles' angles to determine the degrees of the triangles. Meaning of triangle. A triangle is a type of polygon which has three sides and the two sides are joined end to end is called the vertex of the triangle. An angle is formed between two sides. This is one of the important parts of geometry. A. Kinds of triangle according to sides. Number 1. Saline triangle. A saline triangle is a type of triangle in which all the three sides have different sides measures. Due to this, the three angles are also different from each other. This is the picture. Second, isosceles triangle. In an isosceles triangle, two sides have equal length. The two angles opposite to the two equal sides are also equal to each other. This is the picture of isosceles triangle. Next, equilateral triangle. An equilateral triangle has all three sides equal to each other. Due to this, all the internal angles are of equal degrees and each of the angles is 60 degrees. This is the picture of equilateral triangle. Letter B. Kinds of triangle according to angle. First, acute angled triangle. An acute triangle has all of its angle less than 90 degrees. This is the picture of acute angled triangle. Second, right angled triangle. In a right triangle, one of the angles is equal to 90 degrees or right angle. This is the picture of right angled triangle. Number 3, obtuse angled triangle. An obtuse triangle has any of its one angles more than 90 degrees. This is the picture of obtuse angled triangle. Letter C. Interior and exterior angles of a triangle. Number 1, interior angles. An interior angle is an angle inside the shape. From the above diagram, we can say that the triangle has three interior angles. In this triangle, X and Y and Z are all interior angles. The sum of the interior angles is always 180 degrees, implies X plus Y plus Z equals 180 degrees. This is the pictures of interior angles. Next, exterior angle. An exterior angle of the triangle is the angle between one side of a triangle and the extension of an adjacent sides. In the above triangle, A, B, C are interior angles, while D is an exterior angle. This is the picture of exterior angle. Letter D, solve examples. Question number 1. If ABC is a triangle where EB equals 3 cm, BC equals 5 cm, and AC equals 4 cm, then find its perimeter. Solution. Given ABC is a triangle, EB equals 3 cm, BC equals 5 cm, EC equals 4 cm. As we know by the formula, perimeter equals sum of all three sides. P equals AB plus BC plus AC. P equals 3 plus 5 plus 4 equals 12 cm. Next example. Find the area of a triangle having sides 5, 6, and 7 units length. Solution. Using Heron's formula to find the area of a triangle, semiperimeter equals parenthesis A plus B plus C parenthesis divide 2. S equals parenthesis 5 plus 6 plus 7 equals parenthesis divided by 2 equals 9. Now, area of a triangle, S times A minus A, parenthesis A minus B, parenthesis A minus C, equals 9 times 9 minus 5, parenthesis 9 minus 6, parenthesis 9 minus 7, equals 9 times 4 times 3 times 2, equals 3 times 3 times 2 times 2 times 3 times 2 equals 32 times 22 times 3 times 2 equals 6 square units. Now, the second topic that I will discuss today is all about quadrilateral. My learning objectives. At the end of the quadrilateral lesson, students will be able to first, classify quadrilaterals as squares, rectangles, parallelograms, rhombus, trapezoids, or none of these. Second, describe and classify different quadrilaterals using their properties. Number 3, students will be able to use the knowledge that the sum of angles of any triangle is 180 and the sum of angles of any quadrilateral is 360 to solve problems. When we see quadrilateral, it is a polygon having 4 sides, 4 angles, and 4 vertices. The word quadrilateral is derived from the Latin words quadri, which means 4, and latus, which means sides. Letter A. Different kinds of quadrilaterals. There are 6 kinds of quadrilaterals. They are: first, trapezium. It is a quadrilateral with one pair of opposite parallel sides. In the trapezium, ABCD, side AB is parallel to side CD. This is the picture of trapezium. Second, parallelogram. It is quadrilateral with 2 pairs of parallel sides. The opposite sides are parallel and equal in length. The opposite angles are equal in measure. In the parallelogram ABCD, side AB is parallel to side CD and side AD is parallel to side BC. Also, the two diagonals formed to intersect each other at the midpoints, as in the figure given below, is the point where both the diagonals meet. So, length A and E equals EC and length BE equals ED. This is the pictures of parallelogram. Number 3, rectangle. It is a quadrilateral with all the 4 angles of equal measure. That is, each of them is 90 degrees. Both the pairs of opposite sides are parallel and equal in length. This is the picture of rectangle. Number 4, rhombus. It is a quadrilateral with all 4 sides having equal lengths. The opposite sides of a rhombus are parallel and opposite angles are equal. This is the picture of rhombus. Number 5, square. It is a quadrilateral in which all the sides and angles are equal. Every angle is a right angle. The pairs of opposite sides are parallel to each other. This is the picture of square. Number 6, kite. It is a quadrilateral that has two pairs of equal length sides, and these sides are adjacent to each other. This is the picture of kite. Letter B. The properties of each kind of quadrilateral. Number 1, trapezium. Only one pair of opposite sides are parallel. Next, non-parallel sides are called legs. Next, diagonals bisect each other. The length of the mid-segment is equal to half the sum of the parallel bases. Number 2, parallelogram properties is the opposite sides are parallel and equal. The opposite angles are equal. The sum of two consecutive angles is 180 degrees. Next, if any one of the angles is a right angle, then all the angles will be right angles. Diagonals bisect each others. Each diagonal bisects the parallelogram into two congruent triangles. Number 3, rectangle. The properties of this rectangle are the opposite sides are parallel and equal. Each interior angle is a right angle. The diagonals bisect each other and have some the same length. Number 4, rhombus. All sides of the rhombus are congruent and the opposite sides are parallel. Next, opposite angles of a rhombus are congruent. Diagonals bisect each other at right angles. Next, diagonals bisect the interior angles of a rhombus. Last, the sum of two adjacent angles is equal to 180 degrees. Number 5, square. All four sides of the square are equal, and the opposite sides of the square are parallel to each other. Next, the measure of each interior angle is 90 degrees. Last, the diagonals of the square are equal to each other and bisect each other at right angles. Last, kite. Two pairs of adjacent sides are congruent. One pair of opposite angles are equal. An axis of symmetry through one pair of opposite angles. Next, two diagonals are not of the same length. Last, diagonals intersect each other at right angles. Here are the example of solved examples. Example number 1. If the perimeter of a square is 72 cm, then find its area. Solution. Let A be the side of a square. Perimeter of a square equals 4A. 4E equals 72 cm given. A equals 72 divided by 4 equals 18. Thus, side of the square equals 18 cm. Area of the square equals A squared equals 18 squares equals 324 cm squared. Example number 2. The area of trapezium is 180 cm square and its height is 9 cm. If one of the parallel sides is longer than the other by 6 cm, find the two parallel sides. Solution. Let x be the length of the shorter parallel sides, so the length of the longer side equals x plus 6 cm. Height of the trapezium, distance between two parallel sides equals, each equals 9 cm. As we know, area of trapezium 1 divided by 2 times sum of parallel sides times height. Thus, parenthesis 1 divided by 2 times parenthesis x times 6 times 9 equals 180 given. 2x times 6 equals 180 times 2 divided by 9. 2x plus 6 equals 40. 2x equals 40 minus 6 equals 34. X equals 34 divided by 2 equals 17 cm. Now, x plus 6 equals 17 plus 6 equals 23 cm. Therefore, the length of the two parallel sides will be 17 cm and 23 cm. That's all. Thank you.